Hello everyone, this is our lecture on section 1.5. Definition. Consider the system of equations given by the matrix equation A times vector x equals vector b. When b is the zero vector, we say that the system is, and the word is homogeneous. Move this a little bit. And when b is not zero, we say the system is non-homogeneous. Non-homogeneous. Now, a homogeneous system Ax equal to 0 is always consistent. In other words, always has a solution. Right? That is, it always has a solution. Which solution is that? X equal to 0 has a solution that is the guaranteed solution is x equal to 0. Now remember, there was three situations you could have with a system of equations. A system of equations could have a unique solution, infinitely many solutions, right? Or no solutions. There's three situations: unique solution, infinitely many solutions, no solution. Okay, but since a homogeneous system always has at least one solution, right? At least one solution means you're in these two possibilities and not the last one, right? That's not a possibility. So it's either this or this. Okay. Second fact. The solution to a homogeneous system always is the spanning set of 0 or more vectors. Is always the spanning set of 0 or more vectors. Spanning set of 0 vectors is just 0 itself. Okay, so if you have a unique solution to a homogeneous system, if this is there's either a unique solution or infinitely many solutions, but this is always a solution. So if you have a unique solution, this is it. So that's what I mean by a span of vectors. Now we could just say span of vectors. Because a zero vector is a vector, and the span of the zero vector is just 0. Anyway, just that's a little technical point. And then the last fact, if A times V is equal to B, is non-homogeneous, in other words, B is not the zero vector, then the solutions to A times V is equal to B are of the form V plus N, where N is a solution to A times X equal to 0. The course, or why did I say V? A times X. A times X equal to 0. So every solution solution to a non-homogeneous system is of the form V plus N, where N is a solution to the homogeneous system, and V, which is equal to V plus 0, is one fixed solution to AX equals B. I keep saying B. So when you have a non-homogeneous system, you pick one solution. So one solution would be V, something like that. So X equal to V plus N. So you've got one solution. So V is one solution to the non-homogeneous system. And N is all the different solutions you can have to the non-homogeneous solution. So you pick V, which is V plus 0, and that's one solution to this. One out of infinitely many, or one that is the unique one. And then for every other solution in the infinitely many case, you just tack on elements, solutions to the non-homogeneous system. You just add to it, or to the homogeneous system. You just add to it. So we'll see how that plays out. And why is this the case, by the way? If U and V are both solutions to A times X equal to B, then A times U minus V is A times U minus A times V, which is B minus B, which is 0. So, right, U minus V is a solution to the homogeneous system, AX equal to 0. So U is equal to V plus U minus V. U is another solution to the non-homogeneous system, is V plus some solution to the homogeneous system. So there it is. So let's see how this plays out in practice. So describe the solutions to the homogeneous system 1, 2, 0, minus 2, 1, 0, 0, 1, 1, negative 2, and 0, 0, 0, 1, 1, equal to the 0 factor. So describe the solutions to this, right, a homogeneous system of equations. as the span of a set of vectors. Okay, so first let's put it into reduced row echelon form, which it isn't in just yet. Right? Here, we're not asking, like, does it have solutions or not. We're asking, what are the solutions? So you got to put it into reduced row echelon form in order to more easily answer that question. 0, 0. Okay, so to put it in reduced row echelon form, first we got to zero out these guys here. So we're going to do row 2 plus 2 row 3 and row 1 minus row 3. Alright, so row 1 is 1, 2, 0. Now we're subtracting this, so it's minus 3, 0. And then it's still 0 over here because it's homogeneous. And it stays homogeneous whenever you do your row operations. Okay, adding twice to this row, you're going to have 0, 0, 1, and then 3, 0. 0. 0, 0, 0, 1, 1, 0. And now add row 2 to row 1 to zero out. Oh, no, it's already... Oh boy, I zeroed out the wrong things. I got to zero out these, not these. Sorry. That was a mistake. Okay. So I got to do row 2 minus row 3 and row 1 plus 2 row 3. All right, I got to make these 0, not these, because this is the column with the leading coefficient in it. So the columns with the leading coefficients, which are these 3, right, those you have to zero out everything except where the leading coefficient is to get to reduced row echelon form. So this is 1, 2, 0, and then add 2 to that, you get 0, add 2 to that, I get 3, 0. And then subtract it from here, 0, 0, 1, 1 minus 1 is 0, minus 2 minus 1 is minus 3, and then 0, 0, 0, 1, 1. And now we are in reduced row echelon form, right? The leading coefficients are here, here, and here, right? So the free variables are, and how many variables do we have? We've got 1, 2, 3, 4, 5 variables. x1, x2, x3, x4, x5, and the free ones, the free variables are the ones that are not the columns that don't have leading coefficients. So that's x2 and x5. Alright, so the solution set looks like this. Well, the solutions look like this. x5 is free. x4 is minus x5. Alright, x3 is 3x5. x2 is free. And x1 is minus 3x5 minus 2x2. Okay? So the solutions look like this. x1, x2, x3, x4, x5 is equal to, so x1 is minus 3x5 minus 2x2. And then x2 is free, so we just write x2. And then x3 is 3x5. x4 is minus x5, and x5 is free, so we just write x5. So now the solution is described just in terms of the free variables, x2 and x5. So now separate those two variables into two vectors. So I got minus 2x2 plus and x2, and then no x2 is here, 0, 0, 0. Plus the x5 stuff, minus 3x5, 0, 3x5, minus x5, x5. Right? So everything here is described in terms of x2 and x5. So now we separate the x2 vector and x5 vector. Right? Minus 2x2 minus 3x5, and then x2, 3x5, minus x5, and x5. And then factor out that free variable, x2 times minus 2, 1, 0, 0, 0, plus x5 times minus 3, 0, 3, negative 1, 1. So there it is. That's a linear combination of two vectors. Right? So the solutions to the homogeneous system are the span of those two vectors, minus 2, 1, 0, 0, 0, and minus 3, 0, 3, minus 1, 1. Right? So there it is. When you have this homogeneous system, you can expect the set of solutions to be the span of a few vectors. Okay, and when you put, we'll talk about that more later. But anyway, this is what the solution set, this is what the form of the solutions are, which is exactly the set of all linear combinations of these two vectors. Because x2 and x5, they're unrestricted. So this is any linear combination of those two vectors. All right. Now, if you had a non-homogeneous system with the same coefficient matrix, just non-homogeneous in this case. So describe the set of solutions to the non-homogeneous system below as V plus N, where V is a specific solution and N is any solution to the corresponding homogeneous system. Okay, so let's make it non-homogeneous now. Let's put 1, 2, minus 1. Alright, so I'm going to do the same row operations that I did before to get it into reduced row echelon. It's already in row echelon form, but we got to get it into reduced row echelon form. So we got to do these things here. the same ones we did before. It's the same coefficient matrix. I just changed it from homogeneous to non-homogeneous. So what do we have here? We've got 1, 2, 0. And now I'm going to subtract this from here. Minus 3, 0. Add this to here, 2. Right? Oh, I did the same. Add it twice. 1, 2, 0, 0. And then 1 plus 1 is 2. Minus 1 plus 1 is 0. And then this one, or subtract it. No, add it. 0, 2, 0. Next row, 0, 0, 1. Add it twice, or subtract it once. 1 minus 1 is 0. Minus 2 minus 1 is minus 3. 2 minus minus 1 is 3. And then 0, 0, 1, 0, 1, 1. Negative 1. So again, you get free variables x5 and x3. Or x5 and x2. So this one is the free, and this one is the free. And these are the leading coefficients here. All right, these are the columns with leading coefficients, and the remaining columns are for the free variables. So we have that x5 is free. x4 is minus 1 minus x5. x3 is 3 plus 3x5. x2 is free. And x1 is minus 2, or this should have been a 3 there, is going to be minus 3x5 minus 2x2. So the solution set is, the solutions are x1, 2, 3, 4, 5 equal to minus 3x5 minus 2x2. And then x2 is free. x3 is 3 plus 3x5. x4 is minus 1 minus x5. And x5 is free. So now I have the vectors, the variables, the unknowns, x1 through x5, written in terms of x2 and x5 again. But now I got some, some constants in there. So now you separate this into 3 vectors. The constant terms, 0, 0, 3, negative 1, 0. The x5 vector, so minus 3x5, 0x5, 3x5, minus x5, and then x5, plus the x2 vector, minus 2x2, 1x2, and then 0, 0, 0 x2s. Factor out the x2 and x5. So I have 0, 0, 3, minus 1, 0, plus x5 times minus 3, 0, 3, minus 1, 1, plus x2 times minus 2, 1, 0, 0, 0. So there we have it. This is a specific solution to ax equal to b. And this right here, so that's the final answer, so let's box it. But this portion of it right here is a solution to a linear combination that is any solution to ax equal to 0. Because that's the same thing we got in the last problem, right? It's a vector that's a linear combination of these two guys, minus 3, 0, 3, minus 1, 1, minus 2, 1, 0, 0, 0. It's the same vectors as from the last one. Minus 3, 0, 3, minus 1, 1, minus 2, 1, 0, 0, 0. Right? So that's a member of the span of those two vectors, which is a solution to the homogeneous system, ax equal to 0. And this is just one specific solution to ax equal to b, right? The non-homogeneous system. How do you get that it's a specific solution? Well, just choose x2 and x5 equal to 0. Okay. So that's the most general way of describing solutions to homogeneous and non-homogeneous systems. Okay. All right. That's the lecture for this section.